Okay, so this is a problem from the chapter, or the section on complex numbers in Art of Problem Solving. It's a pre-calculus book. And it said you had two numbers, z and w, and the magnitude of z was equal to the magnitude of w was equal to 3. The magnitude of their sum, z plus w, is equal to 2. Find the magnitude of z minus w.
Okay.
I thought you did a really nice job on this problem too. So first I want you to just draw a picture and show kind of the situation that we're looking at here.
Well, so the magnitude in complex numbers is the distance away from the origin. And if the complex numbers z and w both have a magnitude of 3, you can imagine it as a circle with radius 3, and these points z and w are both on it. And then there's a circle with radius 2. Just drawing these. And you can add complex numbers by going to the end of one complex number and then just sort of moving it onto the, like moving the line segment onto the end.
Okay.
It's not.
It doesn't have to be perfect.
So it would end up on this circle with radius 2.
Yeah.
And then z minus w would go the opposite way. So it would sort of go out like this way, and we're trying to find this distance.
Okay, so just from the picture, we kind of expect it to be bigger than 3.
Yeah.
Don't know for sure what it's going to be, but bigger than 3.
Okay.
Okay, so I'll give you some room to work there. How do we solve this problem?
Well, we can use some complex number identities. So if we square this, it becomes magnitude of z plus w squared equals 4. And the magnitude of any complex number z squared equals z times the complex conjugate, z bar.
Okay.
So this would become...
I'm just going to stand back here to make sure we stay on screen.
z plus w times z bar plus w bar equals 4. And so if we do that out, we get z times z bar plus z times w bar plus w times z bar plus w times w bar equals 4. And if we do the same thing for these up here, we get that this squared is 9. So z times z bar equals w times w bar equals 9.
Okay, nice.
So we can replace these with 9. And then we can subtract 18 from this side. So we get minus 14 on this side.
Alright, so you get z w bar plus w z bar
equals negative 14.
Equals negative 14. Alright, actually you have some room over here. Why don't you write that up there, and then you can do the other calculation in the middle. Okay.
Okay.
There we go. Alright, so we're trying to find z minus w.
We can do the same thing with this. You can square it. And we don't know what that equals, so we can just call it x squared, because we're trying to find what this equals.
Yep.
So this becomes z minus w times z bar minus w bar equals x squared. doing this out gets z times z bar from this, which we know is 9, minus w times, or z times w bar, minus w times z bar, plus w times w bar, which we know is 9. This is x squared. And this part in here is the negative of this part up here, so we know that's 14. So 9 plus 14 plus 9 is 32. That's x squared. So this could be either positive 4 root 2 or minus 4 root 2, and since distance can't be negative, it has to be positive 1.
Nice. And we know root 2 is about 1.7.
Yeah.
So 4 root 2 is what? Approximately?
6.8.
Yeah. So we were expecting it to be bigger than 3. Sorry, root 2 is 1.4. Root 3 is 1.7. Yeah,
So it'd be 5.6.
Yeah, we can't have something that's magnitude 3 and add something that's magnitude 3 and get something bigger than 6.
Mm-hmm.
Yeah, so sorry, 1.4, 5.2, right? Yeah.
Oh.
So it's
about
5 point.
Yeah.
Sorry, I can't do math, right? 5.6.
Yes.
Okay. Nice. All right, cool. Hey, those are both really well done. Great job.